Hello everyone, this is Mohsen Saraj from Ozan Engineering. Today I want to show you another workflow for sharing topology uh, in ANSYS Discovery. If you look at this model, for example, as you can see, we have a pipe that we have many bodies, solid bodies inside that. And then for sharing topology, we have maybe thousands of faces and edges to be shared, and if it is a CFD problem, then we need to also build the volume here, and besides the sharing faces and edges and the interfaces between solid and solid, also we need to share the topology between fluid zone and also the solid zones. So this may take very long time when we have many numerous faces and ages. So I'm going to show you how to accelerate this procedure, and instead of sharing topology for everything's here, we can have another workflow that I'm going to talk about this in this video. So instead of working on this very large model, I just cut it into the smaller model. As you can see, we have a pipe that we have solid bodies inside that. uh, One way is that I go to prepare tab and extract the volume for to defining the fluid zone. So just work on the two ends to cap it, and then for interface choose this one, and uh, extract the volume. So if I hide the solid part and the tube, you can see that this is the volume that I have. For example, if I have a section of that, you can see that here I have I have the solid parts in the middle along the axis, and around it this is the volume domain that we have it. So in this kind of problem, it is easy to work with when we have a small number of bodies and faces and edge to be shared. It is easy to go and just do everything for the shared topology here. So let's do it. Okay, you can see that everything shared here because it is a small number of the bodies and a small number of the faces and edges compared to this one that we have thousands of edges and faces to be shared. So let's do it in another way. Instead of in this small step, next step is to just send it to the fluent for meshing, fluent meshing. But let's skip the and remove the volume part and just share the topology here. Share the topology here only between solids. As you can see, only between solids. We don't have fluid volume domain. And let's define the two ends, name it with name selection as cap and 2, and this end cap and 1. And so we did the share topology so far only for the solids, if you can review that, and we don't have the fluid volume domain here. Now for sending that, instead of going directly to watertight geometry, we can go for another one that we call it PMDB. We save this file with this format. Okay, just give it a name, share topology. We save it, and now we go to the fluent meshing with this file and see that how we can perform another workflow that I told you. Okay, this is fluent meshing. Change to watertight geometry the workflow. This is the PMDB file format that I sent it already to here. Read it. This is the file that we have, the geometry, as you can see, only solid parts. No need for local sizing for this video. Let's generate the surface mesh with the and accepted the minimum maximum sizes for the surface meshing. This is the surface meshing, as you can see. Okay, for describe geometry, we say that we have only solid regions. Say yes to capping and extract the fluid region, and no to the rest for the share topology, multi-zone, whatever. Describe geometry. Now we need to enclose the two ends. Then we need to do this to extract the volume domain. This one and the next one, both. Okay, these two, these are the faces that I already defined in ANSYS discovery for capping. So let's do capping. So you can see that now cap surface generated. This one. Now it understands that it needs one fluid region. Say yes. Now creating the region, the fluid region. So you can see that these are the solid parts. This is the fluid region. Now we have it. Add bonded layer, let's leave it for now. Go to generate the volume mesh, accept the default values for this case and say that generate. Okay, now if you look at the model and meshing, you see that this red red color mesh, these are polyhedral mesh that I created. So this is exactly the phyloid domain that we have. Okay, you can see that everywhere I have the volume phyloid zone. So it's created, which is good. And so as you can see that it is very fast, and I just created the volume volume zone here, and you can see that we have conformality in the interface between the solid and the fluid. You can see that everywhere. This is conformal mesh, so it means that it is like we're doing the shared topology. You can see that. Okay, everywhere I have this. So basically I created shared topology between the fluid and the solid in fluent meshing. So the workflow, the new workflow is like this. I share the topology between solid bodies in here in discovery or in space claim, and send out the file with this format for ANSYS fluent meshing. As you can see, there is no volume fluid here, there is no fluid domain here. Then back to fluent meshing, I create the volume mesh, the fluent zone, and conformality for the meshing happens here. Okay, the interfaces between the solid and the fluid. Okay, so I hope that this workflow can help you to make it much faster when you are dealing with very large model that it has thousands of edges and faces to be shared. Let's check this method for a very long model that we have. You can see that we have hundreds of solid bodies with each one also each component has many other solids. So here in this model we have thousands of edges and faces to be shared among the solids, and also here I created the volume by extracting the volume here. So I created the fluid domain here. So, and we have tube, as you can see, this is the tube that I have. Okay, this is the fluid, and these are the solids that we have. So as you can see here, if we go to the tube and make it transparent, so you can see that. So if we want to do the shared topology here between everything, between solids and between the fluid domain, it will take long time. So I stop the video here, and after finishing the shared topology I will back to you. Okay, it took 5 to 10 minutes to share the topology. As you can see, about 2000 faces, 30,000 edges. So if we want to do everything together here, it will take about like 5 or 10 minutes, and then after that you need to send it out for meshing. But now what we are doing here is that uh, if I choose Okay, if I choose to get rid of the volume domain, this is the volume domain that I have. Okay, so I remove it uh, from the body, from the modeling that here I have, and then I will do again the share topology. It took about a couple of minutes, which is much less than when we have the fluid zone and the solid zone together, and then we can send it this with PMDP file format for meshing over there and finishing the sharing topology and having the conformal mesh at the interface between fluid zone and solid zones in fluent meshing. Okay, back to the small model. Okay, I just added boundary layer here, so you can see we have inflation layers there. Besides the conformality, it is like we performing the sharing topology as before now, but with this new workflow that you are seeing that. Okay, you can see these boundary layers also created here, and also for the other side. So let's send out this. First, save it, save the mesh. Let's say that one, and send out this to Fluent. We want to here verify the splitting of the walls between the fluid and solid at the interface between them to wall and shadow wall. You know that for conjugate heat transfer we need the wall and shadow walls. Okay, this is the model as you can see here. Okay, now let's look at the boundary conditions for the walls. See here, you can see that we have wall and shadow walls, that formation of this, that in this way we can verify that the walls also splitted at the two sides of the for the fluid and for the solid parts at the interface between uh, these two zones. So it is also ready for conjugated transfer if we need to do this. So hopefully in this way I could with this new workflow you can decrease the time for sharing topology, and instead of doing sharing topology between every parts of your model, solid parts and fluid domain inside space claim or discovery, you can just create the shared topology between solids in ANSYS discovery or a space claim, and then use fluent meshing to create the volume zone, the volume fluid zone, and then you can create the conformal mesh. And be sure that even here in Fluent you can see that splitting of the walls at the interfaces between uh, solid and fluids, and in this way you can reduce a lot the time. We have some applications that we have very large models with hundreds of thousands of edges and faces to be shared. If we wanted to do this everything stationing topology only in space claim took days, but we verified this workflow that we can do the share topology and creating conformal mesh and the meshing, volume meshing, everything is together. It is just matter of hours. So hopefully you enjoyed watching this video. Thank you for watching.